Hi learners, this is Dr. D. Ramesh Babu, Professor of Practice from SR University, Warangal, India. I welcome you all for this lecture on controlled atmosphere storage for fruit and vegetable preservation. Before going into the lecture, I would like to tell a little more about myself. Basically, I'm a mechanical engineer with a master's in production and operations management and master's in manufacturing and a PhD in controlled atmosphere warehouse systems. Currently, I'm working as Professor of Practice in SR University since 2014. Before that, I had worked in Indian Railways as a Senior Manager Technical, working in a controlled atmosphere warehouse for about 8 years, looking after logistics, controlled atmosphere warehousing, and technologies. I had privilege to visit Israel in the year 2011 and learned about advanced logistics in controlled atmosphere storage. I also worked for about 7 years in Defense Research and Development Organization, DRDO, at the Food Research Laboratory, Mysore, India. Learned about fruit and vegetable technologies, equipment and machinery. Before that, I worked as a production engineer in the refrigeration division of Voltas Limited at Hyderabad Manufacturing Unit. This is all about myself. I'm sure this session would be interesting. We'll be learning about advanced features of long-term preservation for fruit and vegetables. Generally, fruit and vegetables are preserved for shorter periods under cooling conditions, but farmers can be benefited only by availing the better prices in the market when it is off-season. Means during season, due to high production and compared to less demand in the market, farmers will not realize good price. So if we can preserve those for long period, like more than 4 to 5 months period, sometimes up to 1 year period, so definitely better price can be realized by the farmers. They can sell their produce at better price. This can be achieved by well-established controlled atmosphere warehouse. Also would like to tell that I was the project manager to build a 12,000 metric ton capacity controlled atmosphere warehouse in India. That was the first in the country in the year 2006. I had exposure with all the refrigeration system manufacturers, oxygen, carbon dioxide, ethylene control systems and manufacturers, insulation systems for warehouses, various electrical, electromechanical systems, and fruit and vegetable research and development activities. Some of them I'll be sharing in this lecture. Now let us see broadly what we'll be learning in this. We'll be learning about the design aspects of a controlled atmosphere warehouse, what kind of equipment, instrumentation, machinery are used in building and maintaining low oxygen warehouse for fruit and vegetable preservation. So generally we all know cold storage units are used to maintain low temperature to preserve fresh produce. However, controlled atmosphere storage is much advanced than a simple cold storage. In a simple cold storage, we have an insulated room, storage racks, where fruits are kept or vegetables are preserved. And we keep refrigeration systems where the evaporator is installed inside the cold storage room. By running the refrigeration systems, the inside the cold storage temperature is brought down to set point. For example, for fruits, it is between 0 to 5 degrees centigrade, certain fruits. Certain fruits like mangoes, papaya, citrus fruits, it is 10 to 15 degrees centigrade. And depending on the type and kind of product, the temperature is maintained. However, a cold store maintains only low temperature. Now let us talk about advanced technology and controlled atmosphere warehouse. We can see in the picture, the central box indicates the storage chamber where fruits are kept. Now, The outside is ambient air. This rectangular box indicates the storage chamber, and outside air will have normally 21% oxygen, 78% nitrogen. However, inside the chamber, apart from cooling of produce, we also control the gas conditions. That's why the name controlled atmosphere warehouse. We can see on the left, the nitrogen composition inside the control warehouse is 97%. Oxygen level is around 2%. So in ambience, it is 21%. Inside the chamber, it is maintained at less than 2%. On carbon dioxide, 1% level. Tentative figures are given based on the type and kind of produce or apples. The oxygen carbon dioxide levels are varied. But compared to ambient, it is drastically very low for oxygen, for CO2 very high. The ambient CO2 levels are 0.03% in the ambient air. However, in the chamber, it is nearly 1%, many folds increased. So this low oxygen, high nitrogen, and high carbon dioxide helps to preserve the produce for long time. This is the technology. Why it happens? When the fruits are exposed to high oxygen, they take oxygen, undergo respiration, liberate CO2, and gets ripened. Here we are decelerating, reducing the speed of respiration by making the available oxygen low. Here we need to note down one point, that is, oxygen should not be zero again. When oxygen is zero, all science students know, in the absence of oxygen, anaerobic respiration happens, where alcohol is produced. So that should not happen. Oxygen should be available, but should be low. So these controlled atmosphere storage warehouses are also called low oxygen storage chambers. Now for this chamber, what are the systems attached to control these gas conditions? One main thing is the chamber will have a refrigeration system attached to bring down the temperature to desired set point below 2 to 3 degrees centigrade. In case of apples, it is 0 to 1 degree centigrade. However, because we want to maintain the low oxygen, higher carbon dioxide concentration, we also will be attaching a CO2 scrubber. Why we attach a CO2 scrubber for this chamber is, the fruits or vegetables will, during respiration, will generate CO2. That CO2 level should not be very, very high, because very high CO2 is also harmful for the fruit and vegetables. So moderate levels of CO2 will help. So we attach one carbon dioxide scrubber to scrub the excess carbon dioxide. You can see from these arrow marks, the chamber air is drawn through pipeline to the CO2 scrubber. Then only carbon dioxide is separated, excess carbon dioxide, in the CO2 scrubber. The scrub action will remove excess carbon dioxide. So there will be carbon molecular sieves inside the CO2 scrubber, which will absorb CO2, and rest of the same composition air drawn from the chamber is sent back to the chamber again. So here no fresh air is mixed. So this will help the chamber maintain the desired composition. I'd like to acknowledge Mrs. ICA UK and Mrs. Infracool, who was the project companies for the project which I worked earlier. Now let us see the principles of controlled atmosphere storage. The very first thing is reduced respiration rate. One is, we are lowering the oxygen concentration, which will reduce the respiration of the fruits. Second one, we are increasing carbon dioxide concentration. So this together will help reduce the respiration of the fresh produce, thereby delay of the ripening, which will extend the shelf life of the fruits. For example, apples will stay as long as 12 months. These are the established facts. I had worked for 8 years in a controlled atmosphere warehouse at a senior capacity. I handled about 1.5 lakh tons of apples during that period. Another important thing, principle is temperature management. So we maintain low temperature. So this low temperature will arrest or inhibit the microorganism growth. This also helps in respiration control. Another important principle is humidity control. If we maintain high humidity levels in the storage chambers, high humidity is more than 95% RH. So it will avoid any moisture loss from the fruits, because moisture loss from the fruits or vegetables will cause shriveling or shrinkage of the surface of the fruits on one front. On the second side, the fruit and vegetables will lose the weight. Losing weight is losing money for the farmer or buyer. So high humidity need to be maintained in storage chambers. At the same time, we need to avoid mold growth also in the chambers. For example, 100% humidity will cause wetting of the floors, wetting of the surfaces is not desirable. So 95% is the optimum for apples. Another important principle is ethylene control. Ethylene is an enzyme produced by the fruits, even at low temperature. So ethylene scrubbers are connected to the CA chambers so that excess ethylene is removed. In case of apples, ethylene more than 50 ppm is harmful, which will cause excess ripening. So controlling the ethylene levels is definitely desirable. So that will help in delaying the ripening. So compared to a cold storage, now we have understood 3 extra technologies. One is controlling the oxygen level, bringing down 21% oxygen to 1 or 2% level. Second one, increasing the CO2 levels and maintaining that CO2 levels. Third one, ethylene control. And also humidity control. Now let us see the comparison between regular cold storage and a controlled atmosphere warehouse. On the right side, you can see a regular cold storage. It focuses on temperature control only. Thereby, it will help in extending the life for short period, say a few weeks. A normal cold storage cannot hold the fruits and vegetables for long period, even though each fruit, each vegetable has got their threshold shelf life levels. A cauliflower cannot be stored for 1 year like apples, because apples respond well for low oxygen conditions. Citrus fruits, it can be a few weeks, apples up to 12 months, bananas and mangoes for a few weeks can be extended. So compared to regular cold storage, the controlled atmosphere storage will regulate atmosphere condition to slow down respiration and aging, and it is ideal for long-term storage. See, apples are produced only in one season. In India, from Himachal Pradesh, apple harvesting season is August, September, and October. And in Jammu and Kashmir, the apple harvesting season is November, December. So remaining months, where from we are getting fruits? So these fruits are preserved in cold storages, or nowadays a lot of controlled atmosphere warehouses are built in India. There are several projects done by public and private partnership and private companies in India. So on off season, we receive good quality fruits from controlled atmosphere warehouses and cold storages. Let us see more detailed principles about the controlled atmosphere storage warehouse. So this reduced respiration rate. When we reduce the oxygen concentration and increase the CO2 concentration, the cumulative effect is respiration rate of the produce is slow down. Another important control is ethylene control, C2H4. So it is a natural plant hormone that promotes ripening and senescence. This is the reason why fruits ripen. So some CA systems include ethylene scrubbers to remove ethylene from the storage atmosphere. So further delaying the ripening. Extra benefit is availed. Then temperature management. CA storage is always combined with the temperature control. By having refrigeration systems connected, the low temperatures are achieved. So this low temperature reduce the respiration rates and they inhibit the growth of decay causing microorganisms. Then humidity control. So maintaining optimal humidity levels is crucial to prevent moisture loss and shriveling of the produce. High humidity can encourage mold growth, so a balance must be achieved. Then now we will discuss about what kind of equipment are used in CA storage. The very basic thing is gas-tight chambers or rooms. Unlike cold storages, the controlled atmosphere rooms must be airtight. Even a pinhole can make the oxygen carbon dioxide to enter from outside or leak from inside. So chamber should be airtight. So this is required to prevent leakage of the controlled atmosphere gases. So the CA rooms are typically constructed using insulated panels, typically with a 100 mm thickness polyurethane foam sandwiched panels with the stainless steel panels on the both sides. However, the joints need to be sealed with special elastic paint. For example, Ribstyle is a reputed elastic paint manufacturer. We used that paint. So the joints are sealed with Ribstyle paint so that the paint has got low oxygen transmittivity, low moisture transmittivity, low gas permeability. Another important equipment is refrigeration systems. The refrigeration system is essential to maintain the desired temperature within the CA room. So the refrigeration system typically includes a compressor, a condensing unit, an evaporator, and the control systems. Compressor is installed outside the storage chamber. The compressor will receive gas from the chamber after evaporation. It will compress to high pressure and high temperature. The high pressure, high temperature refrigerant will go to condenser. The condenser can be either air-cooled condenser or water-cooled condenser. So there the high pressure, high temperature refrigerant will be cooled to low temperature liquid. So the liquid refrigerant will then pass it to the evaporator through expansion device. And in the expansion device, the liquid expands and it becomes a low pressure, low temperature refrigerant, which will absorb heat from the chamber. Again, that gas will come back to the compressor. The cycle continues. This is called refrigeration cycle. Typically, cold storage and controlled atmosphere systems will have either vapor compression refrigeration systems or vapor absorption refrigeration system. Nowadays, there is a lot of concern about eco-friendly refrigerants, and technologies are very much available with the ozone-friendly and eco-friendly refrigeration systems with refrigerants. Another important equipment for CA chamber is oxygen scrubbers. So oxygen scrubbers are used to remove oxygen from the CA room. There are several types of oxygen scrubbers. As we are discussing advanced things in this lecture, let us see what kind of oxygen scrubbers are used. Then typically a controlled atmosphere storage will have nitrogen generators which will generate pure nitrogen from the atmosphere. A nitrogen generator will have carbon molecular sieve. Nitrogen generator will receive fresh air from the ambient. Fresh air will have 21% oxygen and 78% nitrogen. Now the carbon molecular sieves will absorb oxygen and rest of the thing is pure nitrogen. So 99% nitrogen is then extracted and then stored in a tank. From the tank, through pipelines, through controls, the high nitrogen percentage is pumped to the chamber. The chamber initially will have 21% oxygen, 78% nitrogen. When we pump 99% pure nitrogen, so the oxygen level will come down drastically initially. So that process takes 3 to 4 days time initially, based on the condition and types of foods inside and size of the chamber, volume of the chamber. That's called replacement method. Most commonly used method is nitrogen generation systems, where 99% pure nitrogen is produced and that is pumped with controlled valves through pipes to the chamber. And by replacement method, the inside chamber, airtight chamber will have low oxygen condition. Let us see carbon dioxide scrubbers. So carbon dioxide scrubbers are used to remove the excess carbon dioxide from the CRO. Common types of CO2 scrubbers include lime scrubbers and molecular sieve scrubbers. The first one is a traditional one. These scrubbers use hydrated lime, which is calcium hydroxide, which is used to absorb the CO2. However, the second method is very advanced and almost all the industries use this carbon molecular sieves only nowadays, because the construction maintenance of these scrubbers is very simple and easy. In the first case, lime scrubbers, it is very much manual and a lot of tedious work will be there. So these carbon molecular scrubbers use molecular sieve selectively, they absorb CO2. That is the principle. Let us see other equipment used. Ethylene scrubber. Even though this is not compulsory, it is an optional equipment. So ethylene scrubbers, wherever produce is making high production of ethylene, there this can be attached. Not necessary for each fruit and vegetable. So these are used to remove excess ethylene from the CRO. They use a catalyst to oxidize the ethylene. Other important instrumentation and equipment is gas analyzers and control systems. Gas analyzers are used to continuously monitor the oxygen, carbon dioxide, and ethylene levels in the CRO. There will be sensors in each chamber, storage chamber, connected to a central system where oxygen, carbon dioxide, ethylene levels are measured continuously and controlled. So control systems are used to automatically adjust the operation of the oxygen and carbon dioxide scrubbers to maintain the desired atmospheric conditions. These systems often include PLCs and sensors. Another important equipment is humidity control system. So humidity control systems are used to maintain the desired humidity level within the CRO. These systems may include humidifiers or dehumidifiers. If you want to reduce the humidity, use dehumidifier. If you want to increase the humidity, use a humidifier. Another important equipment is circulation fans. Each chamber will have an evaporation unit and air cooling fan units. So there will be high capacity air blowers installed in the evaporator to distribute the cool air inside the chamber, where cool air will pass through the bins and fruits. So, and also to maintain uniform temperature and gas distribution in the chamber. Now let us see types of oxygen scrubbers. There are 3 types: catalytic burners, nitrogen generators, and PSA units. Catalytic burners they use catalyst to oxidize the oxygen with a fuel source, such as propane or natural gas. These are very traditional methods and nobody is using nowadays. Next one is nitrogen generators. These generators separate the nitrogen from the air, which is then used to displace the oxygen in the CH chamber, as I explained earlier. So most of the nitrogen generator will have technology called PSA, pressure swing adsorption. So these use a molecular sieve to selectively absorb the nitrogen from the air. Let us see about CO2 scrubbers. Lime scrubbers will use hydrated lime to absorb the CO2. Molecular sieve scrubbers will use carbon molecular sieve selectively to absorb the carbon dioxide. The molecular sieve scrubbers are very much available in the market. A lot of companies are making sophisticated CO2 scrubbers which are readily available for all capacities. I recommend the second one to use. Now let us see the operational aspects and applications of controlled atmosphere storage. CA storage is successful for apples, pears, very much. They extend life double than the ordinary cold storage periods because of low oxygen conditions, hygienic conditions, high humidity, and high CO2. Apple fruits are kept fresh for longer periods. Even though each fruit and vegetable requires different composition, which must be adopted based on the origin, type, and variety, and the standard practices of that country. Let us see other technical equipment required in a warehouse. In a warehouse, to move the bins and boxes, basically pallets are required. We also require material handling equipment like forklifts and stackers. A forklift is a machine used to shift the pallets quickly to the storage chambers or draw from the chamber. However, stackers are used to stack the bins one above the other. And various other types of vehicles like reach trucks. Wherever there are narrow space, so these reach trucks are helpful. Or stackers are used for stacking for higher levels. Let us see the other considerations for CA storage, technological considerations. Electric power. So it is better to use electrically operated material handling equipment. The reason is diesel operated or gas operated vehicles will produce emissions, sulfur oxides, nitrous oxides from their exhaust pipes, which is not desirable, which will enter the CA chambers, is harmful. The gases will interact because the chambers are sealed. Once the fruits are loaded into chamber, door is closed, then the chamber is sealed for many months. So there's any exhaust emissions from the metal handling equipment like forklifts will cause harm to the produce. So it is required to use electrically operated forklifts and metal handling equipment. Then definitely when you have electrically operated equipment, so the battery charging maintenance must be properly maintained so that it is available round the clock. And good quality non-marking tires are required for all these vehicles because the vehicles will move within the CA premises like sorting area, grading area, packing area, corridors, because these vehicles will enter the CA chamber while loading or unloading. And also operators need to be given special training for safe and efficient operation within the CA environment. Another important equipment is dock levelers. The dock is the place where loading and unloading will happen. So the dock levelers will bridge the gap between a warehouse floor and the truck or trailer bed. So it will facilitate smooth and safe transition for forklifts, because a forklift will enter the container from the warehouse floor to the container inside trailer and bring the pallets. So this dock leveler will move up and down to match the level of the truck with respect to the floor of the receiving area. Hope I am making sense. There are several types of dock levelers available: mechanical, hydraulic, pneumatic, or air powered. So mechanical dock levelers are manually operated. They use counterbalance systems. They are traditional. However, hydraulic dock levelers are very much simple, easy to use, and highly powerful. They are expensive, but they are very much easy to operate for quick loading and unloading. The pneumatic power dock levelers are used with the principle of airbags to raise and reduce the platform. Okay, they're energy efficient and they require minimal maintenance. Let us also see other requirements during loading and unloading procedures in a CA chamber. Let us see some of the best practices. First one is any fruit and vegetable before storing in the CA chamber, pre-cooling is desirable. When we pre-cool the produce, so when we shift it to the CA chamber, So initially, the temperature pull down will be very, very quick. Say, for example, at the farm level, the fruit temperature is ambient, for example, 25 degrees centigrade. Now, if we load the 25 degrees apple into the CA chamber, it will take 4 to 5 days time to bring down the apple to 1 degree centigrade using refrigeration system. It is always a standard practice to control gases only after attaining the desired temperature. So if we pre-cool in advance, then say fruits are pre-cooled to 10 degrees centigrade. Then a 10 degrees apple kept in a CA chamber to pull down the temperature from 10 to 1 will take lesser time. So we can quickly start the low oxygen conditions. Another important best practice is rapid transfer, because rapid transfer will help minimize the time the door is open, the CA chamber door, by using efficient metal handling equipment and well-trained personnel. Another important thing is air curtains. To install air curtains at the entrance to reduce the air exchange between the CA room and the outside environment. Staging area. Use a staging area to prepare products for loading or unloading, streamlining the process. Staging area, palletization happens, proper transfer to the bins, arrangement of bins, proper planning happens so that either loading or unloading in the CA chamber will be quicker. Then documentation. Maintain accurate records of loading and unloading times, product temperatures, and any deviation from the standard procedures. Another important aspect of CA warehouse is safety. Because the CA storage chamber is at 1% oxygen, it is harmful anybody to enter that chamber. So that's why CA chambers are hermetically sealed. Nobody can enter during storage. Nobody should enter. So for safety, we need to do certain practices like oxygen monitoring, alarm systems, emergency procedures, PPE, and ventilation systems, lockout procedures, confined space entry, mark for it, train the people, signage, fire safety, and regular inspections. All these safety measures are very much required for maintaining CA chambers safely. So the first procedure is install sensors to monitor oxygen levels continuously, so that we know that it is a low oxygen area. Even the corridors in front of CA chambers must be monitored, because when chambers are open, low oxygen will be nearby. It may affect the health of the people. We need to monitor and provide sufficient ventilation when chamber is open. Then alarm systems. Implement alarms to alert personnel of low oxygen. Develop and practice evacuation and rescue procedures. Make people know about it. Then provide required PPE for low oxygen. In case somebody need to enter the chamber, a trained fellow, at least minimum 2 people with an oxygen cylinder and equipment, then PPE should enter. 100% people should not enter CA chambers, with my experience I'm telling. Then ensure ventilation systems. Ensure that ventilation is there to restore normal oxygen levels. Implement procedures to prevent accidental start. Then follow procedures before entering the CA room. Very much important. Provide safety training to all the personnel. Very important. Signage. Mark entrances with warning sign that it is low oxygen and instructions. Fire safety also very, very important. Install fire protection systems at every place. Regular inspection must be conducted to identify the hazards. Specific safety considerations. First one is oxygen deficiency. The primary hazard in CA storage is oxygen deficiency, which can lead to unconsciousness and death of the people. So never enter CA room without proper training and equipment. Carbon dioxide exposure. High levels of carbon dioxide can also be hazardous. So adequate ventilation must be provided. Equipment operation. Ensure that forklift and other equipment are operated safely and that operators are properly trained. Slips, trips, and falls. Maintain clean and organized work environment to provide any slip, tip, or falls. No oil should be on the floor. Frequent check should be done. Forklift should not slip. People should not slip. Chemical exposure. Be aware of the potential for chemical exposure from refrigerants. Let people aware about it and make all the necessary protection about it. For the applications of CA storages, Majorly for apples and pears, the general protocol is for apples, 1 to 3% of oxygen level is maintained. After carbon dioxide in the range of 1 to 5%. The temperature is between 0 to 3 degrees centigrade. For pears, oxygen levels are between 1 to 2.5%, carbon dioxide 0 to 1%. Temperature from -1 degree to 0 degrees centigrade for optimal. Let us see the benefits of CA storage. CA storage benefits in extended storage life. CA storage can extend the storage life for apples and pears by several months, allowing for year-round availability, which will benefit the farmer. Improved fruit quality, because the quality loss is minimal compared to a cold storage stored apple. CA stored apple is much better. It maintains the fruit firmness, color, and flavor. Reduced spoilage. One of the major benefits is it will drastically reduce the spoilage because oxygen levels are low. Microorganisms cannot grow, decay cannot happen. It reduces the spoilage. Market flexibility. CA storage allows growers and distributors to market their produce over a longer period, which helps increasing their market flexibility. So before closing, I would like to sum up here. A controlled atmosphere warehouse is an insulated storage chamber which is equipped with refrigeration systems for cooling, humidity control systems to maintain required humidity, low oxygen systems like nitrogen generators to pump the high percentage nitrogen to maintain low oxygen. Carbon dioxide scrubbers are used to control the excess carbon dioxide levels. Ethylene scrubbers are used to remove the excess ethylene ppm levels. And storage chambers are hermetically sealed. Every CA chamber must be tested with a standard ISO protocol to check for leakages. An entire chamber must be properly insulated. Even the floor should have 5 to 6 layers of moisture barrier, vapor barrier, gas barriers, oxygen barriers, films, then strong floor. And CA chamber also will have breather bag, which was not discussed earlier. Other than CA control equipment, a breather bag will allow any change of variation of pressure in the storage room, either pressure or vacuum. It's like a balloon connected to chamber, generally installed above the CA chamber. So any excess pressure in the chamber, the same composition, low oxygen composition air will pump to that, automatically come to the gas balloon. When there is a vacuum in the chamber, this breather bag balloon will supply that same composition air to the chamber. This will allow, the seals will not break. When vacuum occurs in the chamber due to chilling, the sealing done between two panels with elastic paint may come out. If the sealing comes out, paint comes out, higher oxygen level will enter the chamber. So a breather bag is like a safety lungs for the CA chamber. And also apart from this, CA chambers require a lot of safety considerations for humans because of low oxygen conditions. So with this, I'll be closing this session here. Thank you very much for your patient hearing. Thank you.